We all think we know the story. A single point of fire, a big bang, then 14 billion years of slow, patient building. Dust becomes stars. Stars become galaxies. A calm, predictable timeline. But there's a new eye in the sky. It's looking back to the beginning, to the first light, to the cosmic dawn. And the story it's reading is wrong. Deep in the blackest patch of space we've ever stared into, hundreds of objects are looking back. Objects that are too big, too bright, too perfect. Objects our science says should not exist. The James Webb Space Telescope is not just taking pictures. It's finding monsters. It's looking at a tiny piece of the sky, an area you could cover with a grain of sand held at arm's length. But inside that grain of sand, it's finding a revolution. The project is called JADES, the JWST Advanced Deep Extragalactic Survey. For hundreds of hours the telescope gathered light that had been traveling for over 13 billion years. Light from the universe's first childhood. And what it found threatens to tear up every book we have on how the cosmos grew up. It's a report on over 300 mysterious objects that break every rule we thought we knew. The James Webb Telescope didn't just find one problem, it found 300. And they create three huge questions, three cosmic crimes that need explaining. Number one, the crime of being too big, too fast. According to everything we know, the first galaxies should be small, like tiny villages of stars, wispy, disorganized, and weak. They need billions of years to pull in enough gas and dust to merge with other small galaxies, to grow into the giants we see today, like our own Milky Way. That's the theory, a theory built on decades of work with telescopes like Hubble. But in the winter of 2022, a team at the University of Texas at Austin looked at the first deep data from Webb. They found something else entirely. Galaxies that were already monsters just 500 million years after the Big Bang. That's not childhood. That's a full-grown adult showing up to its own birth. One of them, a galaxy now called JD's GS as 13.0, is seen as it was just 320 million years after the universe began. It's not a smudge. It's bright. It's substantial. It contains hundreds of millions of stars, all packed into a space far smaller than our own galaxy. To get that big, that fast, is like building a skyscraper in a single afternoon. The physics just doesn't work. The standard model of cosmology, called lambda CDM, gives you a speed limit for how fast a galaxy can gather gas and turn it into stars. These objects are driving at 5 times that speed. It's not a small error, it's a fundamental break. You're looking at a photograph of an ancestor who is older than their own parents. It makes no sense. Astronomers measure this incredible age using redshift. As the universe expands, it stretches the light traveling through it, shifting it towards the red end of the spectrum. The more distant an object, the more its light is stretched. An object with a redshift of 10 is seen when the universe was only about 480 million years old. These new galaxies have redshifts of 13, 14, and some candidates even higher. This is the edge of time. When the data first came in, the scientists on the JD's team were certain it was a mistake. They thought they might be seeing something much closer that was just pretending to be old, an object full of dust that just looked red, or maybe a flaw in the telescope's brand new camera, NIRCam. They spent weeks trying to prove themselves wrong, but every check, every test, confirmed the terrible truth. The monsters were real. If you value documented science stories like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. This script is researched and factual, using data from NASA's official releases in the Astrophysical Journal. Now back to the story. Another survey, called SEERS, found its own impossible object, a candidate galaxy named after the daughter of the principal investigator, Stephen Finkelstein. They call it Maisie's Galaxy. It shines at a redshift of 12.5, seen just 390 million years after the Big Bang. And it's not just one, it's a whole population, a hidden continent of giant galaxies in the cosmic dawn. Our previous telescopes, even the mighty Hubble, were blind to them. Hubble sees mostly visible light, but the light from these galaxies has been stretched so far it's deep in the infrared. Only Webb's golden mirrors, 18 hexagonal segments cooled to minus 388 degrees Fahrenheit, can see them. We weren't just looking at the past with the wrong prescription, we were looking in the wrong color. The discovery papers, published in places like the Astrophysical Journal letters, use cautious language, but the message is clear. Our understanding of how the first structures in the universe formed is, at a minimum, incomplete. At worst, it's completely wrong. The universe, it seems, had a secret, early life we knew nothing about. Too big was one problem, but they were also too perfect. Number 2, the crime of being too structured, too soon. The early universe should be a violent place, a cosmic demolition derby. Our models are built on this idea. The invisible scaffolding of the universe is made of dark matter. These dark matter halos should form first, like gravitational wells. Then, normal matter, gas, should fall into them. This process is messy. It's chaotic. Multiple streams of gas falling in from different directions should create clumpy, irregular galaxies. For a galaxy to form a beautiful, flat, spinning disk, like a vinyl record of stars, it needs time. It needs to settle. The constant bombardment from other small galaxies should destroy any delicate structure before it can form. You need at least 8 or 9 billion years of relative peace for a structure like our Milky Way to appear. That was the rule, until Webb broke it. In late 2023, scientists found a galaxy named Sears 212. It's not just a big blob, it looks eerily familiar. It has a bright, straight bar of stars running through its center. It is a barred spiral galaxy, just like the Milky Way. But we are seeing it as it was when the universe was less than 3 billion years old. Our galaxy's bar is thought to have formed only about 7 billion years ago. This one is ancient. Finding a bar is a huge deal. A bar is a sign of a mature, evolved galaxy. It acts like a cosmic fuel line, channeling gas from the outer parts of the disk into the center, feeding star formation and the central supermassive black hole. It's a feature that requires a stable, well-ordered disk to form in the first place. It's like finding a perfectly cut diamond in a raging volcano. The environment is too chaotic. There shouldn't have been enough time for the billions of stars within it to organize themselves so neatly, and it's not alone. Webb's powerful infrared eyes, using an instrument called MIRI, the mid-infrared instrument, can see the glow of cosmic dust, revealing the shapes of galaxies that were previously hidden. All across the early universe, Webb is finding disk galaxies. Not just a few, a lot of them, up to 10 times more than Hubble ever saw. These aren't the clumpy, irregular train wreck galaxies our old theories predicted. These are organized. They are mature. They're spinning like cosmic pinwheels in a time when they should be exploding like fireworks. This discovery forces a hard question. What if galaxies don't grow slowly through mergers? What if the cold accretion model is more important? A model where galaxies are fed by smooth, cold streams of gas from the cosmic web, allowing them to build stable disks right from the beginning. This changes everything. The calm, slow, steady model of cosmic evolution is dead. In its place is something faster, more violent in some ways, but also more efficient and orderly in others. The universe didn't stumble into order over billions of years. It seems it was built for it, right from the start. This isn't just a new detail, it's a new law. A law we have to write from scratch because the old one has been so completely broken by a single image, taken by a telescope a million miles from Earth. If you value documented science stories like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. The script is researched and factual, using data from NASA's official releases and the Astrophysical Journal. Now back to the story. The implications are huge. If galaxies mature this quickly, then stars and planets must form faster. 2. A stable disk is the perfect environment for planetary systems like our own to form and survive. If these disks existed 13 billion years ago, then Earth-like planets could have formed then, too. Life itself could have had a chance to begin much earlier in the universe's history than we ever thought was possible. We've been looking for life in a universe we thought was a teenager. Webb is showing us it might have been an adult for almost its entire life. The timeline for everything from stellar evolution to the emergence of complexity has just been radically compressed. Big, structured. And then there's the third problem, the one hiding in the dark heart of these impossible galaxies. Number 3. The crime of feeding monsters that shouldn't exist. At the center of almost every large galaxy, including our own, there is a monster, a supermassive black hole, millions or even billions of times the mass of our sun. And just like the galaxies they live in, we thought these took a very long time to grow. A black hole grows by eating gas, dust, and stars, but there's a speed limit. If it eats too fast, the energy from the meal, the light and radiation from the superheated material, actually pushes the rest of the food away. It's a cosmic law called the Eddington limit. It's a natural diet plan for black holes. To get to 1 billion solar masses, starting from a typical black hole born from a star, you need to eat non-stop for the entire age of the universe. So finding a huge one in the first billion years should be completely impossible. Webb found them immediately. It found quasars, the intensely bright cores of galaxies where a supermassive black hole is actively feasting. These are the brightest objects in the universe, and Webb found them shining just 600 or 700 million years after the Big Bang. One, called JWST 641, has a black hole that is over 1.5 billion times the mass of the Sun. It existed when the universe was only 690 million years old. How do you grow a monster that big, that fast, from a normal star-sized black hole? You can't. Even if it ate constantly, breaking its own physical speed limit, it's not mathematically possible. It's like finding a blue whale that is only 3 days old. The growth rate is a physical impossibility. So where did it come from? This discovery has forced scientists to seriously consider radical new ideas. One idea is called direct collapse black holes. In this theory, a huge cloud of primordial gas in the early universe, a cloud 100,000 times the mass of the Sun, doesn't form stars first. If the conditions are just right, if the gas is pure hydrogen and helium and it hasn't been polluted with heavier elements from older stars, it can collapse directly into a massive black hole on its seed. This gives the monster a huge head start. Another idea is even stranger: primordial black holes. Black holes that weren't formed from stars at all, but were created in the first fractions of a second of the Big Bang itself, squeezed into existence by the unbelievable pressures of creation. These would be a form of dark matter, and they would provide ready-made seeds for the later supermassive black holes to grow from. Webb didn't just find one, it found a whole population of them, using its NIR spec instrument, a spectrograph that can observe 100 objects at once. Scientists can see the chemical fingerprints of the gas being swirled around these black holes, and they found another paradox. The light from these quasars shows clear signatures of elements like carbon, oxygen, and iron, but those elements are only forged in the hearts of massive stars, and only released when those stars die. To see them in the gas around a black hole just 700 million years after the Big Bang means that an entire generation of stars had to be born, live its entire life, and die, all in an impossibly short amount of time. The galaxy is too big, the black hole is too big, and the gas it's eating is too chemically evolved. It's a triple impossibility, all in one object. The monsters didn't grow in the dark. The dark was born with monsters already in it. The telescope found over 300 objects that violate our understanding of time and scale. Galaxies too big, too structured, with black holes too massive to exist in the universe's first billion years. For 2 years, astronomers have been trying to make sense of it, trying to adjust their models, trying to find a flaw in the data. But the data holds. The mystery deepens. Our entire cosmic story, from the first second to the present day, is being rewritten by a $9 billion telescope staring into the dark. But the final shock wasn't about galaxies at all. It was about something much smaller, much closer, and in some ways, much stranger. In February of 2024, scientists pointed Webb at a place we know very well, the Orion Nebula, a stellar nursery just 1,344 light years from Earth. They weren't looking for galaxies, they were looking for young stars and planets being born, and they found something else, something that, once again, should not exist. They found pairs of planets, floating in deep space, not orbiting a star. They call them jumbos, Jupiter mass binary objects. In their first search, they found 42 of them, pairs of worlds, each several times the mass of Jupiter, orbiting each other in the dark. Our theories of how planets form have a very clear rule. They form in a disk of gas and dust around a young star. They need the star's gravity to pull them together. To find them floating free is strange enough, but to find them in pairs, gravitationally bound to each other but to nothing else, it's a complete violation of the rules. The team at the European Space Agency that found them had no explanation. 2 theories were proposed, and both seem impossible. The first is that they formed around a star, or 2 different stars, and were then violently ejected into interstellar space. But the gravitational chaos required to do that would almost certainly rip the pair apart. For them to be ejected together and stay in a stable orbit is incredibly unlikely. To find over 40 pairs suggests this can't be a fluke. The second theory is that they formed like stars, from a collapsing cloud of gas and dust, just a much smaller one. But here again, the physics says no. A cloud of gas that small, just a few times the mass of Jupiter, shouldn't have enough gravity to overcome its own internal pressure and collapse. The smallest stars, called red dwarfs, are at least 80 times the mass of Jupiter. These jumbos exist in a mass gap where nothing should be able to form. They are too small to be stars, but they are in the wrong place to be planets. The mystery of the 300 ancient galaxies tells us we don't understand the cosmic past. The mystery of the jumbos tells us we don't even understand our own galactic neighborhood. From the edge of time to a star-forming cloud we can see with binoculars, the universe is showing us that our rulebook is too small. The things that shouldn't exist are not the exception. They might be the rule. The cosmos isn't just stranger than we imagine. It's stranger than we can imagine.